So we have my good old favorite student, Anne. There is going to be an Atwood machine, this idea of a mass with pulleys on your test. I guarantee it. And I'll even be more blatant. I'll probably ask you to find the acceleration, then I'll ask you to find the tension. Oh, got to pause the video for a latecomer. Oh. Probably make it worth lots of marks so that I can give you lots of part marks, which means if you can handle the Atwood machine, it's almost free marks. This might be the heavier mass. This might be the heavier mass. I don't know. Whichever mass is heavier, that's the mg that's winning. Whichever mass is lighter, that's the mg that's losing. It's still going to be a job for a free body diagram. So I know I have M1g tension, M2g tension. I noticed that both of these masses are really close. If they were exactly the same, what would the acceleration be? I'm betting when you found A, was it pretty close to 0? Like, I'm guessing, just doing some quick math in my head, less than 1, yes? Yeah, so I can make that prediction just by looking at the numbers, and if I get that, I'll be, yay, I probably did this right. That also probably means that tension is fairly high, because if you're accelerating, that means there's less pressure on the rope on one side. Here, I'm going to guess tension was probably was it in the almost 200 range-ish? Okay, let's actually do this, but who's winning? Looks like M1 is slightly heavier. So what I often do for the Atwood machine is I'll go put a little A like that and a little A like that, just so I know which way things are accelerating. You don't have to, but this is so that I don't look at the diagram later and suddenly pick the wrong winner. Who's winning? M1G. And now I've decided that anything that's pointing down, when it gets to the left side, is going to be a winner plus. So this tension is pointing up on the left. It's going to be a loser minus. Mr. Dueck, why didn't you go tension 1 and tension 2? I think this is all the same rope, one rope. Okay. This tension, you might be tempted to say it's a loser minus because it's pointing up, but if you follow it, I think when it gets to this side, it's pointing down. It's a winner plus. This M2G, you might be tempted to say that it's a winner plus, but if you follow it to this side, I think it ends up pointing up. It's a loser minus. What's that going to equal? I have forces from more than one mass, so it's going to be more than one mass. Jackson is yawning. He knows the punchline because we're losing tension. He's already getting relaxed. I understand that. And to find A, I'm going to divide by M all. So A is going to be M1G minus M2G divided by, and usually on this line, instead of writing M all, I remind myself, Rowan, that we're going to add them together. It's going to be M1, 21.3, G, 9.8, minus M2, 19.6, G, 9.8, divided by 21.3 plus 19.6. I have no idea what this is going to be. I can just tell you it's going to be small. Brackets around the top. 21.3 times 9.8 plus 19 point... No, not plus, Mr. Dueck. Minus, that would have been a silly mistake. 19.6 times 9.8, close bracket, divided by, open bracket, 21.3 plus 19.6. Did you all get... Oh, a typo? Open bracket button didn't work. Open bracket. Let's try that again. Did you all get 0.40733? 0.407? I would take 0.41. If you said 0.40, I would take a half mark off. So if you got this right, I'm going to go 0.407 and store this on my calculator. You'll get 4 out of 4 for this. Otherwise, I would give you 1 mark if I saw that equation, 1 mark if I saw you got the A by itself and canceled out the tensions, 1 mark for the numbers, and 1 mark for the answer. Find the tension in the cord. Doesn't matter which mass you use. I'm going to use mass 2 because tension is a winner, and that will be ever so slightly easier to get T by itself. So I'm going to go tension minus M2G equals M2A. You could also go M1G minus tension equals M1A and do the swappy dance. You'll get the same answer no matter what. I'm going to go tension equals M2A plus M2G. It's going to be, what was M2? 19.6. A, I'm going to write 0.407, but I'm going to use my answer button. Plus 19.6 times 9.8. 19.6 times answer button plus 19.6 times 9.8. Oh, bang on 200. Yeah, that was a kind of a rough guess in my head, but I didn't think it was that bang on. 200.1, I would take that. If I really wanted to go to 3 sig figs, I'll put a decimal there to show you that I did go to 3 sig figs. You don't have to. And tension is a force, units? Newtons. 3 out of 3 if you got that. Otherwise, I would give you 1 mark if I saw that, 1 mark for that, and 1 mark for the answer. Did anybody do it using Mass 1? You get the right answer? 217? You shouldn't be off by that much. I'll have to look at yours, okay? You're going to see something like this on your test then. You're going to see something like this on your test, where I'm going to be pulling something, and I'll pull it to the right because that's what we're used to, and I'm going to have an extra vertical force. In fact, I'll bet you on my different versions of the tests, sometimes we'll be tugging up and sometimes we'll be pushing down. The whole point here is the normal force is not going to be mg. However, it's still a job for a free body diagram. What are the forces acting on this one? Get the obvious one. Gravity. There's a normal force. I think the normal force, and Courtney had this flash of inspiration the other day, is going to be less because 19 newtons of mg is already being canceled out. So the normal force can be slightly smaller than mg. I'll exaggerate it so it catches my eye. There is definitely going to be an applied force. One of the common mistakes kids make is they say, oh, Mr. Dueck, that's the force of friction. The force of friction is 0.48. That's not. That's the stickiness level. The force of friction is the stickiness level times the normal force. So I'm going to draw the arrow of friction in like that. I'm going to assume that we're accelerating to the right. How will I know if we're wrong? I'll get a negative acceleration. What's my equation going to be? I know vertically it's not sinking into the ground like quicksand or flying to like Superman, so I'm going to ignore that. I'm going to write a horizontal equation here. Who's winning? F applied. Who's losing? Oh, I got to give myself not much room here. Okay. F applied. Who's losing? Friction. That equals MA. Want to get the A by itself? I'm going to divide by the mass. I'm going to do that on a separate line in my answer key just to show you what I would give out marks for. So I'm now going to write A equals F applied minus friction all over M. We've been doing it in one line, but I do want to show you I would give you 1 mark for that, or at least a half, probably 1 mark for that and a half mark for that. That to me is an extra step. In other words, if you can get to here, you're 1.5 out of 3. You've got 50% of the question done in my mind. Now what? Friction is what times what? So I'm going to have A equals F applied minus mu times the normal force over M. I don't know the normal force. And I can't quite say, oh, but look, I know another... Oof, there's an extra vertical force here. So I'm going to go even more basic. Savannah, are we sinking into the ground like quicksand? No. Are we flying like Superman? But is there extra vertical forces besides just gravity and the normal force? Then I'm going to say everything up equals everything. And everything up is normal force plus 19. Everything down equals mg. Riley, how would I get the normal force by itself? How do I move the plus 19 over? Yeah. So I'm going to then say this. Normal force equals mg minus 19. Many of you probably got that as the number. I'm going to do this completely algebraically just because some of you may have chosen to do that. I'm going to replace the normal force with that there. It's going to look like this. A equals F applied minus mu bracket mg minus 19 all over m. Now I'm going to plug and chug. I'm running out of room here. I would normally like to write out the numbers. Clearly, I need to redo this quiz and give myself a bit more room or something like that. For now, it's going to look like this then. Well, I can fit this in. 12 minus 0.48 bracket 3.6 times 9.8 minus 19 all over 3.6. Boy, that's writing small. Bracket 12 minus 0.48 times another open bracket 3.6 times 9.8 minus 19. Close off the normal force bracket, close off the top bracket, divided by 3.6. Did you all get an acceleration of 1.1626 repeating? 1.16, 1.2. I would take a half mark off. If you said 1.1, I'd say learn to round off properly. I'm going to go 1.16. Acceleration units? Yeah. If you got that, 3 out of 3. Otherwise, I would probably do something like this. I would give you 1 mark if I saw that, half mark for that. I would give you probably 1 whole mark for finding the normal force correctly. Now, if you went 3.6 times 9.8 minus 19, if you said the normal force is 16.28, if I saw the number 16.28 somewhere, I would say, aha, you found the normal force. That, to me, that's one of the keys to this question. That gets you 1 mark. And then a half mark for the answer. I think that adds to 3, something like that. I might go a half mark here and make that only a half mark and a half mark. I might spread out the marks more, but I'll probably make this one worth probably 3 marks on your test. What if I wanted to give you a nasty question? A nastier question would be if I gave you the acceleration and I said find mu, the coefficient of friction. How would you do that? You'd start here. Where is mu hidden in this equation? What's right in front of friction that I don't like? I'd plus the friction here. I'd minus the MA over. And then I'd divide by the normal force to get mu by itself. And this would be tricky because you'd have to calculate the normal force. There was a couple like that in your homework. I'd feel okay making that like a nasty multiple choice for 1 mark. Antonio, that question is tough enough and enough steps. It should be worth 3 or 4 marks. I just wouldn't feel comfortable making it worth that much because a lot of people would struggle on it, and I don't want to penalize you. So I would feel okay putting it as a written question worth only 1 mark, even though it's about 3 or 4 marks worth of work. Okay. What do they want me to find here? In number 3. Okay. Who's winning? I think the 60. Who's losing? I think the 36. I think this is accelerating to the left. We haven't done stuff that accelerates left very often, but okay. So my equation would look like this. Winner minus loser equals what? M. A, and they want the A by its... Oh, this looked really ugly at first, but actually this isn't too bad at all. In fact, I think I can even do this in my head because it's going to be 60 take away 36, which is 24, divided by 12. It's exactly 2, is it not? B? Sure looked scarier at first, but no. I didn't even need to do the full free body diagram. I just did the forces that they gave me. Speaking of free body diagram, A wants me to draw a free body diagram. There is going to be a question like this somewhere on your test. I'm going to ask you to draw a free body diagram. I'm going to give you space to draw it. Please draw the free body diagram in this space. You can also label the picture, but I won't on your test mark what you put on the picture. I'll mark what you put in this space. So I'm going to do the free body diagram right here. And I'm going to tell you right now, I'm going to be a bit fussy with arrow lengths. What are the forces acting on this? Get the obvious one. What else? Is the normal force here going to be bigger, smaller, or the same size as mg? And I'd be fussy on that. If you did this, I'd take off some marks. Or if you did this, I'd take off some marks. Now, by same size, I mean eyeball it, make it close. You don't need to pull out a ruler and measure it to the nearest millimeter. I'm going to eyeball mine about there-ish. What else? Well, there's clearly an applied force. Geez. F applied. Is there friction in this question?
Yes.
Okay. Bigger, smaller, or the same size as the applied force?
Smaller.
So I would be fussy on that. What if I said to you that this object wasn't moving or was moving at a constant speed?
It would be equal.
Yeah, because in both those situations, A is 0. Then I would look for this arrow to be exactly the same. Eyeball it, but the same length. For now, I'm pretty sure it's like that. Now, you ready for an advanced question? What if I told you this was skidding, slowing down? How big is friction compared to the applied force? What? Say it loud and proud. That's a brilliant insight. We haven't done much like that, but you went back to what we've learned in first principles. Yeah, if I gave you one where it was slowing down, I would look for friction to be bigger. You'd be accelerating to the left, moving forwards, but slowing down, accelerating to the left. That might be another interesting free body diagram to ask you to draw, because all of those are ways for me to ask, have you wrapped your brain around this without just memorizing? Hopefully you've picked up, I have a distaste for memorizing. Let's understand it and reduce our memorization. How many lines did I draw? How many marks is this worth? I'd probably go half mark per line. Okay. So for you to get your full 2 out of 2, those two have to be the same. This should be bigger than that. And try and exaggerate it and make it obvious so that I'm not like, well, Mr. Dueck, it's like a ½ centimeter longer. Make it obvious for me, if you can, please. Is that okay? Find the acceleration. Okay. Winner minus loser equals MA. Oh, Rowan, if it was slowing down and I wanted you to draw friction bigger, I would tell you in the question that it was slowing down. Physics 12, I won't. Physics 12, I'll say you have enough skill that you can calculate this ahead of time and figure out which force is bigger by calculating friction, mu times the normal force, and by, I told you F applied, figure out which way it's accelerating. They want me to find A. A is going to be F applied minus mu times the normal force. Oh, I don't know the normal force. Oh, but look. This is an easier normal force. I really should have done number 4 before number 2, because number 2 is tougher with a different normal. You know what? No, there's no rule that says that test has to go medium, easy, medium, tough. I can scatter the difficulty around. So sure. Is this right? A is going to be F applied. What was it? 225 minus, hey, what's mu? 0.15. M, 100. Common mistake as well. People forget the G. Divided by 100. .225 minus mu times the normal force divided by M. Is it 0.78? Barely accelerating at all. Almost balanced. Really this, oh, didn't mean to erase that. Really this line should be almost as long as F applied. But again, that's why I said I draw these roughly to scale. I just want to know which one's bigger, which one's smaller. That's the key for Newton's laws.
Can you show friction on the free body diagram?
Yes. Half mark off if you didn't. Pardon me? Did you draw an arrow? Then half mark off, because there's four. I need to see 4 lines.
I did, but like on the test. Like, you want that?
Sorry?
You want that on the test though? Like, or like.
Mu is not friction. Mu is just stickiness. It's not the force. In a free body diagram, you're listing all of the forces that are acting on the object. So in this particular situation, if I didn't see 4 arrows, I would not give you 2 out of 2. Did that answer your question okay? I'm having to pick my words very carefully, because if you say, did you want me to show mu? Well, I want you to show friction. If you wrote mu times the normal force, in other words, if you did this, Fn. I'm okay with that, I guess, too. You did extra writing, but okay. So that's why I had to answer it that way. Is that okay, Jackson? Yeah. Let's put friction back on here. In terms of part marks, I notice I have 1, 2, 3, 4 steps. So I probably go a half mark for that, a half mark for that, a half mark for the numbers, and a half mark for the answer. But as always, if you got the right answer, 2 out of 2. There's going to be a question like this as well, where I have a mass hanging over a cliff, and the second mass has some friction. Now, I had somebody say to me, Mr. Dueck, this mass is bigger than this mass. How can a 4.6 kilogram mass make this move? First of all, if there was no friction, if this was pure ice, this could be 100 kilograms. This could be 1 kilogram. It's still going to move, not very fast, but it's still going to accelerate because there is still an unbalanced force. Newton's first says it has to accelerate. So really, it's a question of, is the friction here so big that it can overcome this force of gravity? Ben, you know what it was a good job for? I think you're right. There's more than one mass, so it's going to be M1G. Normal force number 1. Here's the rope. I'm going to call this tension. Here's friction. I'll call it friction force number 1 to go with mass number 1. Okay? M2G, tension. Who's winning? What's causing this to happen is gravity pulling this one down. So now you've decided for me that anything that's pointing down when it gets to that is going to be winner plus. Anything that's pointing up when it gets to that side is going to be loser minus. My equation looks like this. Winner minus loser plus winner minus loser equals M all times A. Oh, relaxation. Nice. I want to get the A by itself. It's going to be M2G minus friction force all over M1 plus M2. I need to make friction force a little bigger. Expand friction force minus mu times the normal force. I don't know the normal force. Oh, I think the normal force is equal to M1G. Mr. Dueck, yeah, Riley, would you ever give us a question like this, where you also had an extra vertical force pointing up or down, and so the normal force wasn't equal to mg? Physics 12. Physics 12, the normal force will rarely be mg. It'll almost always be something more interesting than that. Okay. But this year, no. And now we go for numbers. A is going to be M2, 4.6, G, 9.8, minus 0.19, 6.3 times 9.8, all over 6.3 plus 4.6. I know it's going to be less than 9.8 because there's a hanging mass, and the fastest a hanging mass could possibly accelerate is 9.8. Bracket 4.6 times 9.8 minus 0.19 times 6.3 times 9.8. Close off the top, divided by bracket 6.3 plus 4.6. Did I make a typo? Looks good. Did y'all get 3.06? Yeah. I would take 3.1, but not 3.0. 3.06, not 3.05. And I'm going to use my answer button for the next part, because why wouldn't I? It's less typing and more accurate. How often do you get that? Find the tension. I think I'm going to use mass 2 to find the tension. You could with mass 1. For what it's worth, if you did mass 1, it would be tension minus friction 1 equals M1A, which isn't that hideous. But friction means extra substitution. I'm going to go mass 2. It's going to be M2G minus tension equals M2A. Swappy dance time. I'm going to get M2G minus M2A. That equals tension. Tension is going to be, what was M2? 4.6 times 9.8 minus 4.6 times 3.06. 4.6 times 9.8 minus 4.6 times answer button. You get 31, like even? Wow. 31.0 newtons. If you got that 2 out of 2, I would give you otherwise half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer, and similar for this. Last one. What are they asking you to find here? And then in B, what are they asking us to find? Okay, so we're reversing the questions that we've just done. I haven't quite done one like this. We found the mass on an Atwood machine, but my point, Antonio, is the methods that I'm showing you still work. I am going to give you a missing mass on your test, okay? If you watch the YouTube tutorial, on the YouTube tutorial, I tell the class that I won't give them a missing mass. That was because that class 2 years ago wasn't as smart as you folks. I've decided this year, yeah, I'm going to raise the game a little bit. So, Ben, what's this a job for? I should have gone to you on every question on that today. That would have been just kind of a nice little case. Anyway, okay. M1G, normal force number 1, tension. I think the wheels are meant to indicate no friction, especially since there's no mu sitting there. M2G, tension. Savannah, what's A asking me to find? I'm going to generalize it. It's asking me to find, listen close, an individual force. You know how I'll do that? I'll look at an individual mass. Which mass don't I know? Don't use that one. Which mass do I know? Let me use that one. Look at M1. Who's winning? Who's losing? Oh, this one's so easy that it's tough because people are like, oh, I want to put something in for the loser. No, actually, it's just tension equals M1A. Wow. I already got the T by itself. That's a win. Tension is going to be 4.2 times 3.2. 4.2 times 3.2. 13.44. I'm going to write 13.4, but I'll store this on my calculator because I'm probably going to use my answer button sometime in the near future because it's both less typing and more accurate. And that's a force newtons. If you got that, 3 out of 3. Otherwise, probably 1 mark for that, 1 mark for that, and 1 mark for that. You okay with that, Antonio? Franz, you're alive? Still breathing? Franz, what do they want me to find in B? Which one? I'm going to write an equation for this. Which way is M2 accelerating? Down? Which force is winning? M2 is not a force. Which force is winning? Can you read to me exactly from the Freebody diagram what I put there? You're really way overcomplicating this all the time. You can just read it. Try that again. Which force is winning? Okay, so it's going to be let's do this in red, Mr. Dueck. M2G minus tension equals M2A. Ah! You awake? Franz, how many M2s do I have in this equation? How many would I prefer? Let's get them to the same side. I'm going to do the swappy dance. I'm going to move the tension there and this there. If I do that, I'll get M2G minus M2A equals tension. How many M2s do I have? How many would I prefer? It would be really cool if there was a Math 9 operation that I could... What was that? You're telling me I can factor an M2 out and I'll get G minus A equals tension? Well, Courtney, how would I get the M2 by itself now? How will I move that bracket over, oh pray tell? Divide by the bracket? Oh, and then for the A, that's why I had to find acceleration first, because if I hadn't found acceleration first, I couldn't have done this question. And then I'll use my answer button for the acceleration, so I get an exact... Oh. So you're telling me, Courtney, that it's this? And tension was... That's why I had to find tension. I said I had to find A. I had to find tension before. I'm going to write 13.4. I'm going to use my answer button, and it's going to be 9.8 minus 3.2. Oh, this is so cool. Divided by 9.8 minus 3.2. Get a mass of 2.04. And mass is measured in kilograms. For 3 marks here, I'd probably give you 1 mark if I saw that. I would, well, you know what? Actually, it's 1, 2, 3, 4, yeah. I would probably go half mark for that, half mark for that. I would give you 1 mark if you realized that you could factor half mark and a half mark. If you got the tension wrong, but for part B, you went your wrong answer divided by 9.8 minus 3.2, I would give you full marks for part B. Okay? Can you give yourself a lovely score out of 27? Big quiz. And if you need to lawyer with me, now is the time. Otherwise,